Our next presentation, I admit that I do not speak Chinese. Chinese pronunciations are not my thing, although I've had that DoD paper that I've read about 2027 is true. We probably all will be speaking Chinese pretty soon. But our next speaker, Guanxing Wen, is going to talk to us about DePIN, which ostensibly will democratize infrastructure, but with decentralization. But there are probably some problems. Maybe democracy isn't everything it's cracked up to be. I don't know where to go with that. But we live in weird times. So without too much further tap dancing while they figure out the technical issue that they're having over there. I see that we have the Fourth Estate sitting right up front and center here. This is great. Fourth Estate or fifth column? Yeah, that's what I like to hear. Yeah, it's nice actually having some members of the accredited media in the audience, and feel free to say hello to people that are in the high-vis vests. They're easy to find or avoid, as the case may be. You know that you're on the record when you're speaking with any one of them. Are we close? Almost. All right. Oh, that's pretty cool. I didn't see that mask before. That's pretty serious business. All right. Well, that's. Who came from farthest away?
I think we're ready to start.
Are you ready to go? Oh,
yeah.
Good. Okay. See, now I don't have to do any more of this stuff. Guanxing, take it.
Thank you. Welcome to my presentation. Cracking DePIN. Thank you. Decentralized devices, centralized disaster, and my first time to this Summercon, and Jimbo have given me some gadgets for you to warm you up. And if you like beer, this can keep your beer cool for a long time. So I'm just going to throw and catch up. Try. Thank you. Something about myself. Okay. I'm a security researcher at Certic. We are a Web3 security company in Manhattan. Before this, I spent 8 years at Pangu focusing on lower-level systems like TrustZone, bootloader, and kernel. Yeah. What happened? Thank you. I've also been working on a variety of hardwares, including smartphone, electric vehicles, and all kinds of IoT devices. Now I'm putting this passion into Web3 and blockchain. But don't worry, this talk is not about smart contract. I know this is not very familiar to traditional security people. And this talk is more about what we know much. And so this comes to our topic, DePIN. And so what is DePIN? In Web3 spaces, vendors love creating new concepts to drive up their coin prices. And DePIN, or decentralized physical infrastructure networks, is just one of them. This idea is actually interesting. It's about using blockchain to manage physical devices, allowing them to share their computation resources, memory, and storage. Sorry. Okay, and allow them to share these things. So it's essentially cloud computing. But DePIN aims to solve the centralization problem with the blockchain technology. So we have seen utilizations like AI computation, GPU rendering, network coverage, and file storage. But I decided to focus on the computation part because file storage is a traditional blockchain project which is called Filecoin and has been there for many, many years. And network coverage, from what I see, is just a mixture of a mixtured usage of different proxy protocols. So when we come to the computation part, a question arises naturally, and that is, how does DePIN, or how does this network to limit what can actually run on your device? And if this question is not answered correctly and perfectly, that could lead to very serious security threat. So before digging in my mind, a DePIN infrastructure should be something like this. The user goes through a portal, whether it's a website or a mobile application, and to push jobs to the backend target node. The blockchain plays a critical role here. So the authentication and the task distribution are all handled by the backend on-chain smart contract. So this is what I think before I dig into this project. Of course, the blockchain can also be used as a payment layer naturally, so that the user can pay incentives to the backend node. But in reality, when I look into this project, I notice that the blockchain is not important. Most of the critical jobs are handled still by a centralized orchestrator, like a backend server or a website. So despite having many nodes inside the DePIN network, it's still centrally managed. But some of the time, this central component is not that obvious. It is there. So DePIN is not decentralized like Bitcoin. So what about the security of DePIN? For many people, when they talk about Web3 security, the big bug bounty would occur in their conversation. You may have heard stories about white hat earning millions by reporting a single bug, or hackers stealing millions or billions from on-chain smart contract or exchanges. So because of this, the Web3 industry has developed very good security practice. They open source everything on their on-chain, like smart contract, and also the blockchain code, and every tools they use to build the blockchain. And usually this code are written with memory safety language like Rust. They will also hire independent auditors to double check if this code is secure enough. And it is not uncommon to see that a bug is reported and fixed in just one day. And the researchers will get payment almost immediately. Well, but for DePIN, despite its Web3 rules, doesn't seem to follow the same security standard. So I have seen all this, but most of them are about the smart contract part. The core of DePIN, the proprietary firmware is running on the device, the software running on a PC node, or simply a browser extension, every other components are not audited. And also they are not open sourced. And for bug bounties, it is very rare in DePIN area, even for largest project. Sometimes you cannot even find the official channel for you to report a bug. That means if you can find some issue, there is no clear way for you to notice the vendor. So from the security perspective, DePIN is a scary, unknown, yet interesting playground. It's a perfect place for you to find some new bugs. And for the rest of this talk, I'm going to cover 3 major projects in the DePIN area, and hopefully can give you an overview of its attack surface, how does this entire ecosystem work, and its current security posture. And the first target is render. There's a website called DePIN Scan, which is very convenient. They collect all these products there. So if we sort this product with market cap, you will notice that the render is near the top. Of course, we have to exclude Ethereum and Solana here as they are traditional layer 1 blockchain. They're putting here simply because they have great support on the DePIN ecosystem. And for BitTensor, I didn't find many information and software about it. So let's say with this massive market cap, render is a very good target for us to start our research. Just as its name suggests, Render Network has an open marketplace where you can submit 3D images, movie clips, large language models to the backend nodes through their official website. Of course, you have to pay their render token to make this thing work. And initially, I would like to take a look at their software running on the node to see if they are secure. But unfortunately, I was unable to do that because Render has paused their new node onboarding process. I don't know the exact time they started the pause, but they are still paused this thing till today. So that means I'm not able to get my hand on their software. The only thing I can get access to is their download manager. So when you submit jobs, the result would be many files or clips or frames, and every user who submits jobs will have to use the download manager to handle all these tasks. And this download manager is available on all platforms, simply because it is built with Electron framework. Given I'm using Mac recent days, so our analysis will based on its Mac version. Well, I've also verified this code logic on the Windows version. They're exactly the same, especially for the vulnerability part. At a high level, this app is not signed with Apple Developer ID. This is a very bad practice. That means if you want to run this app, you're going to grant permission manually. And the side effect of this, the signature of this app will not be verified in the future, even if its own code Okay, let's continue. I never noticed this. If someone noticed, should tell me. I don't know. Okay. Where we are? Okay. So this app is in the whitelist of Gatekeeper. That means if you modify the own code of this app, it will not be detected by the system. And the second thing is this app is not protected by the sandbox. So if you can find a vulnerability here, like a code execution, that would have great impact because the app is running with the same permission with current user. And I quickly noticed a direct attack surface. That's the customer URL schema. This allows any application on the Mac, including the browser, to interact with the download manager directly with using a special link. Well, to analyze the code logic behind this URL schema, we have to look into the code logic behind this. And as we have mentioned, it is built with Electron. And there is a tool called ASAR, which is very useful for you to extract all the Node.js script from this app. And after that, with some simple deobfuscation, we're able to read its code logic. And this is the actual code handles the special link. So the foreground code will trigger in one deep link download with the parameter, which is actually the URL we use to pull up this application to the backend. And from the backend side, they will check if the source parameter equals to clipboard. And if so, it will read out the actual parameter and start to parse. Then a file name will be extracted from the actual parameter and saved in a structure field called name. And if we step this everything step by step following the code logic, you will notice there is no sanitizer for the name field. And I think many of you may be familiar with this code pattern. This is a typical path traversal because the name will be passed to create write stream directly. And that means with some .. as the prefix of your file name, you can override any file on this system because this app is running with the same permission of the current user. So we have many options right now to convert this path traversal to a code execution. Like we can override some startup scripts inside the home directory. But as we have mentioned, this app is also in the whitelist of Gatekeeper. So a universal method to build exploit is to overwrite the own code of this app. And this is part of the exploit. We overwrite the electron part of this app. So we have injected some Node.js there to give us a reverse shell. And this is the attack demo. As you can see, the malicious link is sent to the user. And when they click the download button, our exploit will be triggered. And then our payload will download and override the own code of this download manager. So the next time we run this app, our injected Node.js will execute, and that will give us a reverse shell. So in reality, we can send a malicious link to any render user and to have full control of their machine. And there is at least a private key of a crypto wallet with render token inside for you to steal with this exploit. Given the massive market cap, I would say this is a very serious threat to the entire render networks ecosystem. Our next target is called iPhone. It is branding itself as the first Web3 cloud phone. The cloud phone is actually not a brand new idea, but I never tried this before, and I think it's interesting. So literally, there is an Android smartphone running somewhere on the internet, and you can get access to it through your browser or a dedicated mobile application. And the difference for DePIN is iPhone is that they're using DePIN as their backend to provide the computation resource, the running environment of the Android system. And the cloud phone is very convenient for tasks like running a game over day and night without draining the battery of a real smartphone, or managing Web3 airdrops that requires constantly post something on the social media or make on-chain transactions. You can also automate this task with JavaScript running in your browser, as your smartphone is running inside the browser. So this time, we try to target on the orchestrator. It might look like we are penetration testing a website, but it is not. We're actually using this interface to test the backend of a smartphone. So I've several smartphones before, but none of them compares to this experience. You actually use your phone with your browser. You're actually pointing the phone with your browser. So this is the official infrastructure of iPhone. Every instance is running inside a container. So right now at this phase, we try to gain full privilege of one of the container, and so we can have a system overview of what was actually there. You can create a new instance with their website, and as you can see, the instance looks just like an Android smartphone, but it is running inside a browser. And there is also application store, but most of the apps there is Web3 related, like crypto wallet or exchanges. It appears iPhone is using some existing cloud phone solution, but they are not keep everything up to date. Like the Chrome is still version 87, which is ancient. It is vulnerable to numerous public exploits. So you can easily gain remote code execution on a target device by sending a malicious URL there. Normally, for a remote jailbreak to work, you also need a kernel exploit for root privilege escalation. But in this case, this thing can be a little bit complex because the iPhone is actually running inside a container. So not every kernel interface are exposed to the inside the container. And also, I'm not familiar with that containers support Android. So instead of guessing what was running outside the container, I decided to focus on what we have inside the container. And luckily, I do find something interesting. I'm not quite sure backdoor is the right word to describe it. Let's just call it interesting code logic here. So with normal user permission, we can actually extract some binaries from this iPhone instance. And the serverless framework is just one of them. And I noticed that one of the service is talking to a backend daemon using a Unix socket. And it just sent the commands there directly. So following this same protocol, I opened this socket and sent my command there. And voila, I just got my command executed with root privilege. So with this initial root channel, the first thing I want to do is to figure out what was actually running behind this service. And there you see the super init sh guard is what was running behind, and its code logic is very simple. It just grab anything you send from the socket other side and push it to the p open. And that, because this process is running in root privilege, so we just got ourselves the root code execution. And with this root channel, I was able to grab more things from the iPhone instance. And I noticed two other backdoor-like daemon called DGS and MCIU. They have way much more complex code logic. They're using different Unix socket, but they are working just like Super SU or SU. So to use them is very simple. You just execute them, and you will have a root privilege. But notice that you cannot know this customer command names without the root privilege in the first place, because the bin and xbin directory on this iPhone instance cannot be listed with normal user permission. So, but if you know the name, you can just get the root privilege very easy. That's why I treat this as a backdoor. So right now, we have gained ourselves a one-click remote jailbreak exploit chain, allowing us to have the full privilege of a container. We can actually sign this malicious link to any other iPhone users and to have the privilege of their container. But I do find something more interesting than this, and that is the configuration file of this container. I'm not quite sure why this configuration file is putting inside the Android system, and also didn't figure out who is using this thing. But part of this configuration file is a leak of a Amazon S3 bucket's credential. Well, I'm not going to get into the details of Amazon S3 because I'm pretty sure Caleb tomorrow morning will have a very interesting topic about how you can play with the S3 bucket with the write access. But right now, I'm going to say the content stored inside this bucket is critical. They are pre-installed APKs and I think the system images. So with write access, we can actually modify the APK here. And that will give us initial access on all the other containers. And with our root backdoor, we can actually have the full access of all iPhone instances. And this is a really centralized disaster. So it's like you have a zero-click on all Samsung smartphones, and with remote jailbreak, you can have everything running inside their smartphone. And given this is a container, so they are most likely not using trust zone to protect the private keys, chat histories. So you can have everything. And you can also hijack the session. You can just use your imagination. Well, as security researchers, I think we're all very curious about the lower level of a system. So in this case, I'm still curious about what was actually running outside this container. And that leads to our next target, Acer. According to the documentation, iPhone is using Acer DePIN as its backend to provide the computation resource, especially the edge node. And the mention of Qualcomm here is a good sign because I'm familiar with smartphones chipset, and hopefully that can give me an initial pivot for me to find some issues on the iPhone DePIN, Acer DePIN. So let's take a look at Acer. Again, if we sort all these products by social following, you will notice that even Acer doesn't have the largest market cap is extremely popular. And Acer is doing similar things like render. They are both GPU service provider, giving their computation resources to AI and gaming. But Acer is focusing on only enterprise clients. They have node running containers that provide this computation power to other DePIN projects or companies. And they also have indexers for their open market and checkers to verify the performance of those containers. So again, I try to get my hand on their software for the client side and for the node side. But unfortunately, as I told you, they are only working with enterprise clients. So these softwares are exclusive to large companies. And as an individual, I was unable to bypass their KYB to get access to it. And the only thing that is available to me is their edge node. And this is the official device you can purchase from Acer, and this device can join the Acer DePIN as well. So I think this is actually a good result because the device is more interesting than a software. They'll always have something hidden inside. But this thing is not trivial to get. It only has a very small sales window last year. Luckily, I just got my hand on one of them. So by looking at the spec, you will notice this is just like an Android smartphone. But its chipset, Snapdragon 865, is a little bit old. So for this kind of smartphone, I would say I can only pay maybe $200 or $300 for it. But Acer Edge is selling for $1,400, which really caught my eye, makes me more curious about what was actually running there. To use it, it's very simple. You just use a mobile app to connect to it with Bluetooth, configure its network, and then you scan a QR code displayed on the screen, and that will bind the mobile app with the device. And after that, it will run automatically. It will earn you Acer token every day by providing your computation power to the Acer DePIN. So when I got this device, I immediately started to looking for interface that allow me to figure out what was running inside. And the USB port seems to be a promising attempt. But some of you maybe noticed this is a USB-A port. So that means it's most likely this port is running in host mode. And this is very weird for Android system because normally Android is running as slave, waiting for your computer to plug in the cable and send some commands there. So my best guess is this port is using some kind of recovery method for you to plug in your thumb drive with system image inside. So when this device is break somehow, you can recover it to the normal status. But according to their official documentation, this thing becomes more weird. They said a USB port has no practical use. This is from the hacker's view, this is like an engraved imitation. It's like putting a button on the wall labeling, do not push. What did they expect was going to happen? So at this moment, I'm 100% sure there's something hidden behind this USB port. I just need to figure out what. So I quickly connected with a USB-A to USB-A cable to my laptop. But unfortunately, nothing popped up. So we have to go with the hard way. We have to tear down this device and maybe dump something from the storage. But before that, I noticed there's a debug port here. If any one of you have opened up your router or your IP camera, this debug port or UART port would be familiar to you. Normally, this will give you a root shell on this device. But before actually wiring cables from this port to my UART connector, I noticed a more convenient interface, and that is a switch near the USB-A port. So I flip it. As you may suspect it, this turns the USB into a slave mode. So after that, I plug in the cable again, and the ADB shell pops up. Yeah. And that gives me the initial access for me to dump a lot of things from this device and start to analyze the system. And the first vulnerability I discovered is within their network configuration phase. As I have mentioned, they are using mobile application to configure the network of this device, and specifically they are using Bluetooth. But there is no proper authentication, and actually no authentication at all. So that means anyone within the BLE or Bluetooth range is able to connect to this device, reconfigure its network, forcing it to connect to our malicious access point. And with strong antenna, you can extend the BLE range to not meters, maybe kilometers, making this a viable remote attack surface. And after that, we can put ourselves in the man-in-the position in the same local subnet of the target edge node. So we have many options for further attack, like we can target on some services that are exposed on the local subnet. Another interesting thing is that every services running inside the edge node, like the OTA, the download, and CMD line, they are talking to a backend server with the Mosquito protocol. And the Mosquito protocol is very common in IoT network. So basically, there is a backend broker running services that listening to different channels. And all the services are subscribing to different channels. And the manager can publish messages on those channels, and it would be broadcast to all the subscribers naturally. And the problem here is that they're not using TLS certificate verification. So given that we are in the man-in-the-middle position, we can just prove the DNS record, making the edge node to believe that we're actually the broker. And there we have got our chance to send commands to the device directly. And from this huge attack surface, I have found vulnerabilities on all those services. But the most direct way to get a code execution is their CMD line service. It allows you to execute shell command directly. And I think this is most likely the way that the broker is pushing jobs, pushing tasks to this DePIN node. So as you can see, the CMD line service is subscribing to a channel called he/cloud/device/serial number. And the only missing part is the serial number. But the serial number of this device is very easy to get. It is the same with the Bluetooth name. So you listen to the Bluetooth channels, you will know the serial number. So when we publish some command on this channel, the onMessage function inside the CMD line service will start to grab CMD line from it. And if the CMD line doesn't equal to the 3 keywords, it will be sent to popen directly. And that gave us the remote code execution on this edge node. And this is our attacking demo. And our exploits start by scanning the nearby BLE devices, and then we'll connect to the Ether edge and reconfigure its network that connect to our access point. After that, we push commands through the CMD line services by spoofing the broker domain. And with the remote code execution, we can maybe just display an image on the device. Thank you. What makes this thing worse is that I noticed that I don't actually need to be in the local subnet to trigger this vulnerability. And the reason is that they have no proper authentication on the backend broker domain. With username admin, password admin123, anyone can publish commands on those channels. So we can target every node that connect to the internet. And from what I see, this is a really disaster. The time I find this vulnerability, I think there are 62,000 nodes running alive. And the number right now is nearly 70,000. And collectively, this node can generate Aether token that are worth $310,000 every day. And you can also use all these nodes as traditional botnet, let them attack other things, or you can let them just do crypto mining, maybe earn you some extra dollars. Also, given that we have the root privilege on all these containers and all this node, we can also pick and poke on those containers, and maybe you can find some private keys of crypto wallet. So how did this vendor respond to my report? For Aether, I was managed to contact their engineering team. And they confirmed everything, and they started the fix. It took them a long time, but after maybe 4 months, they have fixed all the things. But when I asked them about acknowledgement, they become silent and never respond to any message from me. So for iPhone, again, I managed to connect to their team. They confirmed everything and promised to me to fix. But after a while, I think in January this year, their engineering team tell me they are not going to fix anything anymore. And later, their CEO sent me an email telling me that we are moving to a new direction. And I suppose that new direction is away from their existing security responsibilities. Yeah. Bold pivot. And for Render, with its largest market cap, it's the least responsible. I cannot find the official way to notice them about this issue. The only thing I can find is their Telegram group of their foundation. So I talked to their employee, and they gave me this email. It's a general support email. I'm pretty sure this is not the right way to report a critical remote code execution issue. But this problem is too serious to wait, so I just sent my report there. And they replied, oh, this has been forwarded to the relevant person, followed by no update. And finally, they tell me, oh, we don't have any new information. And after that, whatever email I sent to them, they did not respond to me anymore, and they become totally silent. But lately, just before this talk, I come back to their software, and I noticed that they did fix this thing in the very next version after my report. They add a specific regular expression to filter my payload. I don't know what to say to them. Yeah, right now we have covered every component inside the DePIN infrastructure except blockchain, which, as I said, plays a minor role. So we have talked about the download manager of Render Network and its remote code execution. We have talked about iPhone and its backend S3 bucket, which is centralized disaster, allowing us to control all of their instances. We have also talked about Aether and its backend Mosquito services, which allow us to have full control of all their edge node. All of these issues are huge centralized point of failure. So in conclusion, the financial incentives in DePIN make these products far more attractive to attackers than traditional IoT networks, because hackers can steal private keys, tokens, and massive computation power. Yet without effective reporting channels and incentives for vulnerability disclosure, the security of DePIN will remain poor. Why would any security researcher help them with their projects if they offer nothing in return? So the DePIN industry is in a high-risk environment for both users and investors. It is, however, an attractive and vulnerable playground for the attackers. Okay, that's all for my presentation. Thank you. Okay. What's the question? So sorry, can you be loudly? You mean when one scientist report is that I'm using my company as the original or myself? Yeah. For the first two, I send them using my company's email. And for the last one, I tried both ways, with LinkedIn, with Telegram, with email, with Twitter, with every method I can use. Yeah. Okay. What's your question? Uh, um, because traditionally I'm focusing on the Web 2 security or the traditional security. So I'm actually exploring the physical layers of Web 3. And I actually done other research like hardware wallet, and DePIN is just one of them. There are also the physical device running inside the Web 3 industry. I actually bought a Helium device, and I didn't pick and poke every DePIN products. I only picked some of them, but Helium is, of course, one of them. But I didn't find anything on Helium. They are really doing, I think, better, way much better security than other DePIN products. And they are very they have a long history, and also they have bug bounty. They have auditors. They have a lot of things that I mentioned this DePIN products doesn't have. Okay. Sorry, I didn't listen. You mean, did I look into apples? Uh, Previously, I have done research on Android system most likely, uh, but I didn't look into apples. You mean, do I have proof that I actually find these things, not they find these things before me? Uh, I think you can just look any of them and it give you similar results, except helium. You are also very welcome to talk to me off the stage.